Welcome to Saxon Algebra 1 Lesson 66, and this is the third edition of Saxon that we're using. Hey, welcome to Saxon's Algebra 1 Lesson 66, and this lesson is on simplifying radical expressions and the square roots of very large numbers. So let's get right down to it. Simplifying radical expression can help you solve an equation. It involves removing the root when possible or reducing the radicands, the number inside the radical symbol, as much as you can, as much as possible. Okay, so let's do a few problems together. We have the square root of 18 plus the square root of 8. Now, remember factoring, prime factorization. That's what we're going to employ here to solve and simplify these expressions. So 18 factored out would be 9 times 2, and basically that is 2 times 3 times 3. And 8 is 2 cubed, or 3 twos. So when we see a pair of numbers together under the radical sign, the square root of 3 times the square root of 3, we remember, is just simply 3. So we would bring that out, as I've done right here, on the outside of the radical sign and leave what is left. If there's 2 numbers left under there, I'd multiply those. Alright, so here I've got 3 square root of 2, and then this set of 2's is going to come outside, and it will be 2 square root of 2. Now I have two like terms that I can add because they both are something square root of 2. So I simply add the 3 and the 2, and I get 5 square root of 2. Okay, let's do the next one. 8 square root of 27 minus 3 square root of 75. Alright, 27 is 3 cubed, so I've got 3, 3, 3. 75 is 25 times 3. 25 is has a square root of 5. So if I factor all that out, and then I circle my pairs and bring them outside, and then I have to multiply, if there's already a number outside, I have to multiply the one I'm bringing out by the one that's already out there. So here I brought out this 3. The 8 was already there, so I have to say 3 times 8, and I get 24 square root of 3. Here I brought out the pair of 5's, and there was already a 3, so I say 5 times 3, and I get 15 square root of 3. Alright, now I have two like terms, as you see. 24 square root of 3 minus 15 square root of 3. I'm just going to simply subtract 24 minus 15, and I get 9 square root of 3. Alright, let's do the next one. Square root of 27 minus 3 times the square root of 18 minus 6 times the square root of 45. Alright, we know from our other problem the square root of 27 is 3 times 3 times 3. Factor that out. 18 we've already done before. It is 3 times 3 times 2. And then 45 is 9 times 5. 9 breaks down into 3 times 3. Alright, so I'm going to bring those pairs out. I've circled in the first one the 2 3's, and I bring that outside, and I've got 3 square root of 3. Now, in the second one, I bring out 3, and there's already a 3 there, so I'm going to have to multiply those. Same thing in the last expression. I've got a pair of 3's. I bring it out, and I multiply 6 that's already there times 3. So let's do that. 3 times square root of 3 minus 3 times 3, which is 9 square root of 2, and then minus 6 times 3, which is 18 square root of 5. Now, you can see I haven't done anything else to that because it is as simplified as it can be. Square root of 3, square root of 2, square root of 5, none of those are like terms, so they cannot be added together. Alright, when we're dealing with very large numbers, we can look at the number of zeros and look for an even number of zeros, and that's important. Alright, here I've got 4 zeros, so I know that 100 times 100 is 10,000. So I can really break this 10,000 down into 100 times 100 times 5, and instead of doing all that factoring out. And I can bring that pair of 100s out, and it will be 100 square root of 5. Much easier than factoring all the way out those large numbers. All right, here in this one, we have an odd number of zeros. So I'm going to take the even that I have, which is 100,000. So I know that 10,000 times 10,000, I'm sorry, 1,000 times 1,000. There's 3 zeros, there's 3 zeros for these 3 and these 3. So to get 1 million, I would have 1,000 times 1,000. And here I've got 40 million, so I'm going to have 1 million times 40 is the breakdown. So 1,000 times 1,000, and then I'm going to break down 40. It is 2 times 2 times 2, which is 8 times 5. Alright, so if I've got this pair of 2's, I'm going to bring it on the outside. Pair of 1,000's, bring that on the outside, and multiply what is left, which is 2 times 5. And I get 1,000 times 2 to the square root of 10. And when I multiply 1,000 times 2, I get 2,000 square root of 10. And that would be my answer. Well, let's work some practice problems. Alright, 24 square root of 24 plus square root of 48. Let's factor both of those out. 24 I know is 8 times 3. 8 breaks down into 2, 2, and 2. So I'll circle that pair of 2's and bring it out, just like I have here. Brought it out. And then what is left, I'm going to multiply. So 2 times 3, I'm going to have 6. 48 is 8 times 6. Well, 8 is 2, 2, 2, and 6 is 2 times 3. Now here I've got 2 pairs of 2, so I'm going to bring that out twice and multiply those to get 4. And then I have square root of 3 left. Now square root of 6 can't be simplified, and square root of 3 cannot be. They are not like terms, so this is the final answer. Alright, 2 square root of 18 minus square root of 27. We know that 18 factors into 2 times 3 times 3. I'm going to bring that one set of 3's out and multiply it by the 2 and get 6. And 2 is left, so 6 square root of 2. 27 I know is 3 cubed, so 3, 3, 3. If I bring the pair out, I have 3 square root of 3. Again, these are not like terms. They cannot be added, so this is as simplified as it will get. Alright, and then finally, we have 50 million. Square root of 50 million. Well, I've got 1, 2, 3, 4, 5, 6. So I said that 1,000 times 1,000 there, and then 50 will break down into 25 times 2, which is 5, 5, 2. I've got a pair of 1,000s, I'm going to bring it out. A pair of 5s, I'm going to bring it out. And then what's left? Square root of 2. Multiply 1,000 times 5, you get 5,000 square root of 2. And we are done. I'll see you back next time for lesson 67.